Okay, good morning. Only Orabi is here. Thank you, Orabi, for your attendance. Probably, do you hear me? Yes or no? Meryem is here. Orabi is here. Yes, yes. We can start actually. Thank you, Meryem and Orabi. I can record your name. Also, today we're gonna continue with the sensor and sensorless operation of electric motor drive system. Hello, Meryem. Last week we started with the BLDC motor. I said you it's very generic motor type, brushless DC motor. It's very commonly usage. It has a common usage area in the industry. However, lots of uh, usage method are available for brushless DC motor. Okay, I said you we started with the DC. Now brushless DC. Brushless DC, you can remember they are easy manufactured, high torque capability, high power capability in servo system, in robotic arm, in electrical vehicles, in wind turbine, etc. We are using lots of time brushless DC motor. However, don't forget it, brushless DC and permanent magnet synchronous machine are same topology. We are using two of them for different application. However, we have drive technology for some purposes. Okay. Sometimes we are using sensor, sometimes we are using sensorless operation. These are control methodology. These are interested with the control methodology. You can imagine you have you are work here you are working in washing machine company, for example. Also you are working in white good company. Generally, this type of company use sensorless motor application. Why? Because they are selling 10 million product per year. Okay, this is very important. One sensor, you can imagine $1. If you sell 10 million white goods, this means that 10 million dollar only one sensor. So they are using sensorless control topology. This is important. So, in your profession life, you will see if you design robot arm, if you design servo control, if you design high precise application, you will use sensor. However, if you need reduce to your total cost of if you use non-sensitive application, you will use sensorless motor control approach. Okay. For example, in the papers, in the literature, lots of researchers focus sensorless control application. Why we can not use every time sensorless motor? I said you below of 10 percentage of the rated speed, sensorless application is not response very high dynamic response. Okay, for example, you cannot track very precise position estimation in sensorless. Why we say like this one? Because sensorless motor control application approach is depend on back EMF estimation. What's the back EMF estimation? Lots of time you hear from me and or another professor in the motor application. We say it every time. Speed is mean that voltage. Current is mean that torque. If you estimate speed, so actually position, you know the position is the 1 over s derivative of the speed. So you need to know voltage of armature. So it's meaning that if you want to estimate speed, you need to know back EMF. In typical motor equation, you know we have, for example, Q-axis voltage, VQ equal resistance times armature current plus inductance of phase winding times di dt, derivative of current, plus back EMF. At this situation, if you estimate back EMF, you can control your motor sensorless. Okay. However, in the low speed region, estimation of back EMF is very hard. Lots of researchers developed an algorithm, lots of researchers developed an estimation methods like a model reference adaptive system, model predictive controller, also some Kalman filters, also signal injection methods. However, in this course, this is not an advanced electric drives. This is electric drives. For example, in master class, we are focusing sensorless motor control topology. However, in the bachelor level, we need to know differences between the sensored and sensorless. Okay. Well, let's begin with the purpose of both sensor control and sensorless control briefly today. When driving a brushless DC motor, the system needs to execute motor commutation, which is when the motor moves from one position. Where is my where is my yes, pointer here. When the motor moves from one position to next, for you can imagine we are in the one state, and then we will go to also another one. In motor control application, we have two direction. Somebody say forward, somebody say reverse, etc. But originally in the world literature, we can say clockwise, counterclockwise. You see, this is clockwise, clockwise, counterclockwise. In the red arrows indicates clockwise. Okay. Also, if you rotate opposite of clockwise, this means called as a counterclockwise. It's important. So if your motor moves from one to two, to do this, you must know where the rotor position is relative to the stator, so that you can apply a magnetic field that force the rotor to move in the desired direction. Actually, in briefly, we can say if you want to control your motor, you must know magnetic field position. Good. In sensored control, it implies that you are using physical sensors. Sorry. Sorry. Sensors control use a position sensor. Last class, I said we use Hall sensor, we use encoder, we use resolver. Okay. However, in sensorless control means that you are using other methods. I said Kalman filter, etc. You remember. What is the aim of this approach? We must estimate rotor position without any physical sensor. Also, in the industry, for example, in Turkey, lots of company focus defense industry, focus automotive industry, focus aerospace industry, etc. This industry is called as a very high standard they have high regulation, high level application, etc. In this area, we are using lots of type physical sensor. I said to you, Hall sensor is not sensitive. Encoder is sensitive, but they are dividing according to their sensitivity. For example, we have absolute encoder. Absolute encoder is mean that it detects position high accuracy. However, another side we have incremental encoder. So we can divide the encoders incremental and absolute. Okay, absolute is mean that it detects position of motor, detect absolutely. However, incremental encoder detect the position 1 over, for example, 2500. It's very sensitive, but it's not sharp. Also, another type, resolver, third one, Hall sensor, encoder, and resolver. Resolver is like an electric machine. It detects very accuracy motor position with using a sinusoidal signal. Generally, they are using defense industry and automotive industry. Okay, these are just an literature knowledge. Now, what is the sensor control? Sensors are used to determine the actual location of the rotor relative to stator. While there are many different types of this position sensor, I said resolver, encoder, Hall effect, these all fundamentally do the same thing. Okay, I said different capability, but their aim are same, which is to give a signal, which is an indicator of when to commute the motor. Every time we are following same thing. We try to find correct position. Sometimes we are obtain relatively, sometimes we are obtain very limited uh, accuracy. Last time I mentioned about the sensor, especially resolver is a sensor that use in second page we have it. For example, resolver is here. Actually, this is encoder. This is encoder. This is optic encoder. This is Hall sensor, Hall effect sensor. Okay. We have no picture here for resolver. It's not a resolver, it's encoder. Maybe I said to you, Hall effect sensor has three legs. Here you see U, V, W. Okay. One of them VCC. VCC is mean that voltage supply. One of them ground. Another one signal. 1 and 0 signal. We have three legs. In encoder, we have A plus, we have A minus, we have B plus, we have B minus, we have Z. Also ground and VCC. If you have a 7 cable, this is called as an encoder. If you have a 5 cable, 3 cable, it's called as a Hall sensor. But don't forget it, every Hall sensor detect one phase. If you control brushless DC, you have three phase. Three phase is mean that U, V, W, ground, and VCC, 5 cable. 5, if you have a 5 cable for position, this is probably, it is Hall sensor. If you have a 7 cable, this is called as a encoder. I think resolver is important because we are using very limited time resolver. If you need high resolution, high system cost, aerospace, also avionic, also defense industry, you can use it. What's the specialty of resolver? In the resolver, you can see here a graph I indicated. You see this as the sine and cosine output of resolver. One signal generates sine, one signal generates cosine. These two signals will tell you the angular position of the rotor to high degree of accuracy. This signal needs to be processed by a microcontroller to determine where and when to commutate. Second one, encoder. These are encoder signals. A, green one is B, and these are Z. Encoder is either an optical or electromechanical device. It's attached to the shaft of your motor. Okay, we have lots of type encoder. I said to you incremental and absolute and incremental. Also, we have some cheap encoder with the very low resolution. For example, optic encoder. If you write a Google optic encoder, you will see their price is very low. The encoder will output a pattern in zeros and ones with respect to rotor position. You can see here 1 and 0. Encoder generate 1 and 0. Also this is the A channel of encoder. Green one B channel and these are Z. Okay. Yani if you have an oscilloscope, you can check your output of the signal. You will see like this one. In this graph, you are seeing encoder output. Some encoders will output 256 or more pulse minimum. Generally, we are using minimum 256. Lots of time. If you have enough money, if you have enough high circuit and microcontroller, generally it goes 2500 PPR. What is the PPR? If you use Holtz encoder, you will check PPR number. PPR is mean that pulse per revolution. Okay. And the last one, Hall sensor. You see here low resolution respect to Hall encoder. To compare these three sensor and controller device, lastly I said resolvers give you high resolution, very accurate position. Encoder high resolution than Hall effect sensor, can but lower resolution than resolvers. Hall sensors gives you low resolution, but they are more simple and lower cost to implement. Okay, what is the sensorless control? This control schema uses no position sensor, so it must estimate the rotor position in relation to the stator by using parameters. How can detect the rotor position of stator? Winding resistance or back EMF determine where or when to commute the motor. Okay, we need to know back EMF. What is back EMF? I mentioned as a briefly in the starting of the class. Now we can say we can give us some details. What is back EMF? Back EMF is back electromotive force or back EMF. Back EMF is voltage induced on a wire when a changing magnetic field is applied. You can see in the presentation Faraday law. In the motor stator winding, we have number of turns. So we have a time variation. Also we have B. B is mean that magnetic field. Okay. Faraday law is very important for us. Okay. Maybe you can remember from electromagnetic theory, or maybe you can remember electromechanical energy conversion. To find out where this voltage comes from and what affects it, we will look at Faraday's law. Faraday's law says that the voltage induced in a wire is proportional to the number of turns of a coil of wire, changing magnetic field, and the area of the coil. You can see that as you spin the motor. Now, normally these are the animation. If it animation,
motor will be turned, it generates sinusoidal back EMF. You can imagine only. This sinusoidal signal goes to infinite. The magnetic field on the stator is changing in every turn, and voltage is generated on the face of the motor due to the Faraday's law. This voltage can be in two shapes, one of them sinusoidal, one of them trapezoidal waveform. Last class I said to you, we can divide the brushless DC and permanent magnet synchronous machine according to their back EMF waveform. It is depend on your motor design types. You can see this is sinusoidal back EMF. This back EMF voltage actually correspond the specific angle of rotor, meaning that you can use the back EMF to determine the rotor's position. If you see trapezoidal back EMF, you can see in the right side of your screen, this is brushless DC motor. Okay. Also sinusoidal back EMF generate permanent magnet synchronous machine generates sinusoidal. We have two type AC motor with permanent magnet. This is critical. Please check. Please listen carefully. We have two type back EMF. One of them sinusoidal. Sinusoidal is mean that permanent magnet synchronous machine. However, if you have trapezoidal back EMF, right side of screen, this is mean that brushless DC motor. Okay, this is important. Lots of time you will see these waveforms in your professional life. Now, every back EMF type, each of phase is offset 120 degrees from each other. This is Wien phase. Okay, you can imagine second phase, track it after 120 degrees, and the next one 240 degrees. This is why P is within the sine term. This, I said to you, if your motor spinning as a faster, you can obtain larger back EMF. Okay. If you learn how generator is working, you can check what is the machine name? Wait me. Drill. If you use a drill machine, for example, you can couple a drill machine to your motor shaft and then in a 3000 RPM rotate using a drill to your motor with a coupled, you will see your motor will generate back EMF, end of winding. This is wind products and voltage. Okay. Also, another important issue for us, how we can detect back EMF. Also, how we can decide commutation time. One way to do this in the junction with trapezoidal control is during the commutation state. The back EMF of the undriven phase can be observed through what is referred to as a window. Our main aim, this is called as a window method. We need to detect phase A, phase B, phase C current level. For example, when the motor is in this commutation step, the voltage on phase A can be read with an ADC to determine what's ADC. Generally, all motor control application use microcontroller if you developed high performance, high communication capability. Moreover, if you want to develop sensorless control application, you must use microcontroller. How you can read the current and voltage? You need to use ADC module of your microcontroller. ADC is mean that analog digital converter. You are capture analog signal and you will convert it to digital, and then you can convert digital signal to real values. For example, you can imagine you must calculate your motor voltage. You are using dividing voltage divider. Okay. Don't forget it. Some microcontrollers use 3.3 volt. Some microcontrollers use 5 volt. Okay. Now we are installing a circuit. My maximum voltage level is 100. 100 is mean that in your microcontroller 3.3. Okay. If you read 3.3 volt in your ADC channel, microcontroller will understand it. I am reading 3.3 volt. It means that 100 volt. Okay. If you read, for example, 1 volt, you can 3.3 is equal 100. 1 volt, what? 1 times 100 over 3.3. Probably it means that now I am reading nearly 40 volt. This is ADC working principle. Again, the voltage on phase A, for example, we can return to estimation. Okay, a voltage when the motor is in commutation step, the voltage on phase A can be read with an ADC to determine what the back EMF voltage of the phase is. This back EMF voltage can then be used to determine when to commutate the motor. Most algorithms use the zero crossing of back EMF to determine where to commutate the motor. This zero crossing is when the back EMF crosses 0 volt. Now, we are in the good point. Zero crossing method. Okay. What is zero crossing method? In brushless DC motor, we are using zero crossing detection approach. Now, how can, please image it in your screen. These are 0 point. These are 0 point. These are 0 point. If, what's the mean of 0 point? If you detect or estimate of every 0 point, bakın, look, this is 0. If you detect 0 point of your stator voltage, it means that you can estimate back EMF value. If you detect every 0 point of phase A, phase B, and phase C, you can calculate position of motor. We have 6 states in brushless DC. Okay, 0, 1, 2, 3, 4, 5. 0 degree, 60 degree, 120, 180, 240, 300, 360. If you estimate zero crossing of these all phases, you can check every critical 60 degree of your motor position. Okay, this is very important. For sinusoidal motors, driving a motor with sinusoidal current means that there is not a phase to create the window used in the windowed method. So another way to determine the back EMF is calculating it rather than directly measuring it. What's the measuring of the back EMF? Now, we are using typical motor circuit diagram. We have R, we have L, also we have R values L. Yani please listen to me carefully. Every motor have RM or R, lots of time we are saying R, and L and back EMF. This is single line diagram of motor. We have a voltage, motor armature voltage. We have R, we have back EMF. Main equation, back EMF voltage equal U minus I time R minus L times di dt. Another equation, back EMF equal radian value of the speed omega angular velocity times key A back EMF constant and sine theta. Sine theta is position of motor. Actually, what we know, phase voltage. Phase voltage is mean that we have battery or we have supply voltage, U for example, not U. It's mean that Vm. For example, you have electric vehicle, you have battery, your battery voltage, for example, 200 volt. Your duty cycle, you will arrange it. Your duty cycle 50 percentage. If your battery apply 200 volt, if you have 50 percentage duty cycle, it means that in your phase voltage, you can calculate very easily. 50 over 100 times 200, it will be equal 100 volt. This is called as a phase voltage. In brushless DC motor, it's very easy. In induction machine and another motor type, it's hard, but the brushless DC motor is work as like the DC motor. We can calculate using an PWM. Another one, we know motor inductance, L value. Every motor has nameplate. In nameplate, L or data sheet, every data sheet gives us L value, inductance value of motor. Also, next class uh, I will say parameter calculation methodology. It's very important, I think, for electric drivers. Also, another one, motor resistance R. This is wrongly motor inductance L, motor resistance R. Also, motor back EMF constant. Key A, don't forget it. Generally, we have two constants in the motor. One of them back EMF constant, one of them torque constant. Torque constant is Kt, back EMF constant Ke. Generally, we can accept Ke equal Kt. Okay. So these parameters depend on motor design. So motor company must give you Ke constant value. If you have no, don't worry, you can calculate easily with an oscilloscope. Also omega. Omega is speed of your motor, but this is angular velocity. Okay, we have two type of velocity. One of them angular velocity, one of them revolution per minute. Lots of students make same mistake. Omega is not RPM. In your nameplate of motor, RPM is generally is written by company. For example, if your motor nameplate has 3000 revolution per minute, it is called as a mechanical speed. Okay, omega is radian speed. Actually, you can convert it easily to P over 60 times RPM value. Another one, current. You can easily check your current using a current sensor. Now, what we don't know, it's critical. We don't know the V back EMF, we don't know the theta, we don't know the I. I is current, I said, but we don't know I, but we can sense I easily. You need to use every time current sensor, so um, we can exclude of I from what we don't know section. What we don't know, V back EMF and theta. Maybe mm, when when spinning a motor, we know the applied phase voltage, which is supply voltage times the duty cycle. Also, we know inductance of motor, resistance of motor, constant key A, and speed of motor. I said what we don't know is the back EMF voltage and the angle of rotor and current. I said. How can detect current? I said you can use current sensor. Oh, it's possible. Another method. Also, there are many ways for sense the current. One way and cheap way, don't forget it, you can use shunt resistors. Okay. What's the shunt resistor for detect the current? Using the shunt resistor in an ADC, the current of the phase can be read. Nearly 5 minutes ago, I said the way of the current sensing using GaN shunt resistors. You can remember 200 voltage equal 3.3 and 10 voltage, for example. How can you read? You can remember. This approach, very generic. Also, this allows us to calculate the back EMF and rotor position using the two equations on the bottom of your page. If you write these two equations, also you can detect correctly current. Now we have two unknown parameters. We have two equations. We can solve very easily. Okay, this is very simple brushless DC motor sensorless control approach. Now before we talked about directly comparing sensorless and sensored control. Now let's go cover the three application of brushless DC motor. Three different type of applications of motors are, don't forget it, torque, speed, and position. Torque application are where the desired results to deliver a torque. What is the unit of torque? Newton meter. When we use it, for example, in drill machine application. Torque application, for example, cordless drill. Okay, in your home probably, or in your life, you obtain in a minimum one time cordless drill machine because it does not matter what speed the motor is turning at. The desired result is to deliver enough torque to drive in a screw. For example, in the drill application, we are waiting correct torque value. Speed applications are applications where the motor is trying to achieve a speed and hold that the speed with constant speed. Okay, in fan application, in pump application, we are waiting constant speed approach. Also another one, position application. Position applications are applications where the motor is moving from a specific position to another specific position. For example, gimbal. Okay, in drone, in the avionics system, also webcam application, etc. We want to hold a position. The three different motor application Generally, we can say we have only three type of application. They have different requirements and different challenges. Torque application demand zero or slow speed torque. An example of this is a drill that is screwing in a screw, and the screw hits something where the torque needed to drive in the screw is larger than the drill can deliver. So the motor will spin down to zero or slow speed, but the drill will still need to deliver torque to screw. Another one, speed applications. Speed applications require a motor to hold a specific speed. So the motor needs to withstand changes in torque without changing speed. For example, laptop fan. They are spinning at a constant rate and something blocks the air to the fan. This will decrease the torque required to spin motor. So we can say we have cascade control system here. In the inner loop, we are control current. Outer loop, we are control speed. And another outer loop is position. You can imagine inner loop current, another loop speed, and the last one position. Okay. Actually, speed applications are a very good example where sensorless control and sensorless algorithm have been designed to work well with. The requirement of withstanding changes in torques is deal with many different sensorless control algorithms. Today, we covered very simple brushless DC sensorless control approach window method. It's very simple. It is not accurate, but you can control your motor very limited accuracy. However, we have only two equations and two unknown parameters. In the sensor I said you, we know already position of sensor. We cannot wait for hard control techniques. It's very easy, but sensorless is more hard to the sensored control techniques. Evet, interesting approaches are available. These are type of the brushless DC motor application area. Lots of time you will use it. Okay, today we can finished. It's our second makeup course. Now, do you have any question about your final project? Do you have any course, any question? If you have a question, please write the comment section. I try to help you. Or in this week, you can come to office for your question. Also, attendance list, wait me. I have 4 students, good. Week, wait me. Week 5, attendance list. Good. I think these 4 students will be lucky. I will give extra point for attendance. Okay. Don't worry, please come to class. Meryem, Nejati, Ahmed, Orabi, and Hamza Mohabbet, Ibrahim. Okay, good. Also, how is it going, your project? Did you start or no? Prof, as we're going to do PCB board as a group, we should make, wait me, as we're going to do PCB board as a group, should we make same board? Okay, no problem, Orabi. I said 4 people, 4 students design together, no problem. 4 students is good.
but I am waiting PCB design. Okay. However, I am not waiting PCB production. You will buy component from market. It's very easy. In Turkey they are available. You can use Pertinax. Okay. Yani I am waiting only design of PCB plus implementation of PCB. However, not product in China. You can use Pertinax. Okay. Okay. Another course ours will be this week. Yes, 2nd of January is stuck in PCB design. Wait me. Why? I said you website. Did you wait me? Where is my website? Wait me. I will show you. Yes. Digital screen? Yes. Why you are stuck? No. You firstly you will download KiCad software and then you will follow this step. What is the starting point? Orabi? You are here or here? Okay. And please focus. I will give your grades for this design. Okay. For this design and implementation. I am waiting. End of the course. Electronic board. You need to control using an Arduino like this one. A DC motor. Okay. Code is available. Card is available. You cannot product it. You will build it only. Which one? Capacitor, for example. Yes, it's available. No, some students come to office. It's available. Um, how can I help you now? Wait me. Capacitor. For example, okay, in week come to office. Okay, on Tuesday, for example. Yes, I know. Yani it's available actually. How I can show you? I have no KiCad. Do you want to present us your KiCad screen? If you don't want, no problem. On Tuesday I can help you. But it's available. THT bak. True hole. You can write true hole capacitor. You will see your capacitor. Only you need to select it. Okay. What's the dimension of your capacitor? Firstly, you find it. You must find it. Which type of capacitor? How much volt and how much? Do you remember? For example, in the screen, 100 nanofarad. Okay, probably you cannot find it. 100 nanofarad. We can check together. you can write 100 nanofarad. It means that 0.1 microfarad THT capacitor. Elektrolytik. Elektrolyt. I can check here. For example, Mauser. Critical point. Wait me. These are, for example, these are SMD, not through hole. In your design, you must use through hole. What's through hole? Through hole is here. These are through hole. This is okay for you, for example, 50 volt, 0.1 microfarad. I check data sheet of them. In your KiCad screen, you will see capacitor. I suppose that it is correct probably. You will decide dimension of your capacitor. For example, you can select using these two pins dimensions for example, P, where is it? Rated voltage. What's your rated voltage? I don't know. But I suppose that rated capacitance, this one, no, 0.1 micro, no, 0.1. Where is it? For example, you can select 0.1. These are not 0.1. Tamam. 0.1 microfarad, correct. 1,5, 15 microfarad. This is not a 0.1. Do you remember your microfarad value? For example, okay. We can check another one. 0.1, yes, did you write it? 0.1, okay. We can check another company, for example. Aluminium. How much volt? Okay, not important. We can select 10 microfarad. Probably they are same. If you select rated voltage, for example, okay, no problem, 50. We can accept 50 volt, 1 microfarad. It's not necessary. 0.1 is very classical electrolytic capacitor. Their dimension will be same. Don't worry. We can select 1. Now, if you use 50 volt, 1 microfarad, 4 times 7. What's the 4 times 7? 4 is D, 7 length. D4. Yes, here. D, if your diameter will be 4 and P is important. What's P? P is the dimension of 2 pin. It will be 1.5. You can select, please open your KiCad page. Last week, as students come to my office, we select together. Parameter selection screen, probably you know in the KiCad. You can write THT capacitor, and then if you click any one, you will see dimension of capacitor. If you select 4 diameter and p value, I don't remember the correct name of the p. P is the 2 pins dimension. Okay, clearance actually. It is a clearance of 2 pins. 4 times 1.5. You will see. Actually, it's available. Also, another issue. KiCad forum. You can download all footprints KiCad forum web page. Okay, please try to find it. If you don't find it, please come to office Tuesday with your group friends. We can check together. Okay. Please focus your project before exam. You need to buy from internet all components and you need to build your circuits. I am waiting DC motor control application and report. How many days are remain? I don't know. I check probably 10 or 15. I don't know. Okay. Thank you for your attendance today for students. See you on Tuesday at Tuesday.
Hello, Professor.
Yes.
I want to ask about the motor. Should we prepare as well the motor?
Mm-hmm. No, ask again. I don't understand. Your voice is coming very bad. Yes.
Are we supposed to bring the motor itself and connect the horse circuit, or just the PCB that is considered
Yes.
hybrid?
You will design PCB using a KiCad. Okay. To do here, okay. You will design a PCB KiCad.
Okay.
And then normally if you have a time, I want to product your PCB. However, we have no time. You will build your PCB using Pertinax. What is it? Like this one. Wait me. Pertinax with your hands. Pertinax PCB. You will buy like this one a Pertinax, and then you will buy your components from internet from Turkey because it will be very fast and it is very cheap components. Okay, maximum 200 liras will be maximum cost. I am waiting PCB design. I am waiting Pertinax solution. But the end of the semester, I want to see a motor will be turned with your code, with your circuit. Did you understand? However, I am waiting KiCad design. But we don't product it. We don't product like this one. Where is it? Yes. We don't product like this one. Normally, I want it, but we have no time because it goes from China and then return to here, shipment money, etc. It will be very expensive. We design it to the here. I will see this figure. 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 I am waiting, and simulation. However, also I am waiting this circuit, but with your Pertinax. I am waiting sine circuit, but using Pertinax, not product PCB like this one. It's understandable?
Yes, sir. It's clear.
Okay.
Okay. Thank you.
Okay, thank you. See you Tuesday.
See you. Have a
We have
good
a class Tuesday at 2 o'clock. Bakayım. 2 o'clock mu? Evet. We have 2 o'clock course. Bye bye. Have a nice year. Have a good year. Goodbye, everybody.